car brakes. Okay, we have several tasks, they all have the same priority, so the scheduling is done using round robin. Now, if you try to move anything in the car, nothing will be working because it is still unlocked. Okay, but we have two keys. This one is unauthorized, so it won't unlock the car, but this one is the authorized one and it will unlock the car. So if you try this one, access denied, and if you try to move anything, nothing will work. But if you try this one, access granted, and the car is unlocked now. Now you can try anything and this will be working. Our FOID task works using counting semaphore. When you unlock the car, all the semaphores are given so that all the other tasks have to take this semaphore before they start working. And they give the semaphore after they finish their implementation. And when you unlock the car, when you lock the car, the RFID semaphore takes back all these semaphores so that if any other task tries to take it, it won't be able. And now we can lock the car back. So if you try anything, it won't be working. Thank you.
In the mirrors, we used a joystick, which is a sensor that is connected to an analog pin in the Arduino. We only use the X direction because we're only moving one servo motor in one direction. So the joystick, as an output, gives us ranges from value from 0 to around 1020. In the middle, it's around 500, and when it goes this way, it's 0, and when it goes this way, it's towards 1000. Now, the servo motor takes input from 0 to 180, so whatever the joystick gives out, we put it in the map function to map it from 0 to 180, but in order to adjust it a little bit, we made it from 10 to 170. Now, if we move the joystick this way, the servo motor turns this way, and if we move the joystick the other way, it turns the other way. In order to simulate a seat belt, we have a button that is connected to the Arduino and gives a signal to another pin that is connected to the buzzer. So whenever the seat belt is off, the buzzer is on. Now this only occurs if the engine is on, if the car is moving. So for example, now the car is moving, so you can hear it, you can hear the seat belt and the buzzer turning on. Now if we press this button, there is no sound anymore, but you can't hear it because of the car. Because of the car's sound is very hard, the wheels, we just took this pin off so you can hear the car. Now this means that the engine is running and this LED simulates that. Now you can hear the seatbelt. Now if you press the seatbelt button, it turns off and there is no sound anymore. And if you turn it back on again, there is this audible warning for the buzzer.
We needed an edge bridge to move the 4 wheels at the same time. Also because moving a DC motor needs an edge bridge, because if you connect it directly to the Arduino, it might be dangerous because the DC motors send current in the opposite direction, which might harm your Arduino board. So we needed an H bridge. The H bridge, as you can see, this pin is the ground pin. The one beside it on the left is the VCC, which takes input. We needed to supply 12 volts to the H bridge in order to move 4 DC motors. If you only need to move 2 DC motors, you can still supply only around 5 or 6 volts. This pin is for the signal pin. So this one is the one connected to the Arduino board with the PWM pin, so you can control the DC motor speed. For example, if you wanted to perform at the maximum speed, you set the PWM pin to 255. Maybe if you wanted to set it to the mid speed, it would be around 125 or 122. These 2 pins over here are the ones which you connect to the DC motors. You can connect it to more than one DC motor. In a perfect case, you need to connect. You can connect each side that the H bridge can supply 4 DC motors. However, for some reason our H bridge only supplied to one part of the H bridge and the other one didn't want to work at the same time. So only one functioned while the other didn't function. So I overcame this problem by connecting the pins together. So the 4 DC motors are connected to these 2 output signals, the negative and positive. Now the car is unlocked, so if you want to start the engine, we press on this button. As you can see, now the wheels are working and the seat belt buzzer, as my colleague mentioned, is working. So if you want to turn it off, you press this button. Now it's turned off. If you want to stop the engine, you click again on this button. We needed to use a water level sensor to simulate the fuel level. As you can see now on the screen, it displays high fuel because the water level sensor is inside the water. If we take it out, the screen will display low fuel, which means that the water level, or in this case the fuel level, is low.
There is a raindrop sensor. It tests as follows. Put some drops and rain appears on the LCD. To simulate lane tracking and keeping sure that they're on the same lane along the road, we simulated by an LDR tracker. It measures the contrast between the displays it has, it measures the contrast between the white and the black screen for both visual and audible alerts to the user that you're off track.